Hi class. So this week we're going to do lab 5 vector forces. So you click, log on to Canvas, you click on modules and click on this PDF file, and then the recording will be uploaded to this location, the instructions, and data can be you can download the data from under the subfolder lab 5 vector forces. Okay, so after you click on the vector forces PDF file, this is going to what you're going to see. So let me bring this up. Let's see vector forces. All right. So vector forces, basically the goal is to find the third force that balance the two given forces, and there are several ways to do it. One is the first one is called the experimental method, which means that you're given a force table and you're given two forces, known forces, and then you're going to experiment with the experiment and find the third force that balance the two. And so the design, so the setup is like this. So you have this what we call the force table, and you have three pullets, and they are and those three pullets have threads tied to a ring, and the pullet, when you have the setup, make sure that from the side view, the thread should be parallel to the tabletop, so that they are parallel. Okay, and you're going to provide forces in the thread. We'll put mass on the mass holder. So the whole thing here, mass plus the mass of the holder will provide the tension in the string, and that tension will be the force. Okay, so two forces will be given, and the third force, let's say if this is the one, if this is the force that's given, meaning that you are given a specific amount of mass on the pullet and given an angle, and likewise this is, let's say we call this force A and force B, then this is the one that you're going to find experimentally. If we were to do it in the lab, you would experiment with the amount of masses on the pulley, and also the position of the pulley on this degree plates, in order to find out the angle of this third force. And in order to determine whether the third force balances the other two, you would lightly touch the ring. Okay, so there's a ring there. You will lightly touch the ring, and if after some motion that when you reach balance, then the center post should be at the center of the ring. If it's not, then you have to adjust the mass on the pulley, and also the angle of the pulley, or the position of the pulley, in order to get to a balanced situation. Okay, so that's the first method. We call that experimental method. So the second method is what we call the component method. Okay, so for component method, we know that based on this diagram, you have the force one, you have the force A, force B, and then if you do the component method, we will be able to determine the resultant of this force A and B, and this resultant force we call that FR. So this is the one that is the summations of A and B. So this is the resultant force, and the third force which we call FE, should have the magnitude that is equal to the magnitude of FR, by pointing in the opposite directions. In other words, these two forces, they will balance each other. So once you resolve vector A, once you resolve vector B, and find out the x component of the sum and the y component of the sum, that will be the x component of the resultant force and the y component of the resultant force. And then this force that balances two, meaning that if this has x component, this has y component, then this must have a component that has a magnitude of negative x and negative y such that, you know, they balance each other because they have the same magnitude but pointing in the opposite direction. Okay, so that's the second method, the bicomponent. So in other words, before you before you do anything, you can just, you know, if you're given force A, if you're given force B, you can resolve the vector into the x and y, and then find out the resultant of A and B, and then change the sign of the resultant force. That will give you, you know, the component for the third force. Okay, and the third method is what we call the graphical method, which we're not going to do since you know, it will be kind of difficult for you to get to do it. You have to draw it with a protractor and have to be very precise. So we're not going to do that. So we're not doing this. Okay, the graphical method. All right, and then so procedurally, you know, this is like you're given two forces, which I'm going to, you know, after I bring up the data, I'll let you know what are the magnitude and angle of that two forces. So so you would just proceed, you know, and then with the you know, just based on the data you're given, and you can find out the you know, and then follow the steps in the analysis and complete the you know, the work. Now, I just want to mention, you know, draw your attention to step 3E, where it says that the angle can be calculated by using the inverse tangent of the y component over the x component. This is only true when the angle is measuring from the positive x-axis. However, this will not hold true if you do that using the you know, the numbers that you found, because that vector vector r, the third force is not in the first quadrant. So I do not recommend you to use this. What you can do is that this is always true, just like what you learn in class, that if you want to calculate or the tangent, you know, to find the angle, that will be inverse tangent of the opposite over the adjacent. That is always true, okay, regardless which quadrant the vector is in. So you use that principle instead of using this one, because this one is good only when the vector is in the first quadrant, and you know, and then in other quadrants that you'll get you might get a wrong answer. So this is the one that will always give you the right answer. Use the inverse tangent of the opposite over the adjacent, and that will calculate the angle, you know, based on that, you know, based on the right triangle that you choose. Okay, all right. So let me bring up the data, because okay. So let me just the data. So the three forces. So you'll be given you're given two forces now, because the third force, if we were to do it in the lab, of course, this is you know, this is the one they are going to find, you know, in the lab. But because we're not doing that in the lab, so I'm just providing that to you. So the three forces basically are already given. Okay, so you have this, you know, force A, force B, force C. We put, you know, we put certain amount of you know, mass on the mass holder. Now remember, the mass holder also has a mass. So altogether, the mass plus the mass holder, you know, will give you this mass. Okay, so you have 35.4 you know, grams on pulley A, and this amount of force on pulley B, or mass, and this amount of mass on pulley C. So you need to figure out the mass. I'm sorry, the force. How much, you know, how much force is provided by the mass on the pulley. So you just need to use this number and then convert it to kilogram and multiply by 9.8. That will give you the amount of force. Okay, so we do that calculation, enter in this column. Okay, and the angle is already given. So force is along the x-axis, force B is along the 95 degrees, and force C is actually 240.7. Okay, so so this So then once you have the information in front of you, then you can actually start putting the some of the things in here, because force A has an angle theta, have angle 0, so you can actually put 0 there, and the angle for force B is 95, so you can put 95 there. Okay, and then FC, well, you're already given an angle here, so you can just put that down. So all this are already given. Okay, you don't have to do any calculation. Now, the calculation wise, you need to do this calculation, okay? And then for the simple calculation, you just show one. For example, you just show A, how you got the other force, then that'll be good. Now for this one, you can, and then let's say you already calculate, we know that the angle is 0 for FA, and the force, you will, you will have a number there. So based on that, you need to resolve vector A to find the x component and the y component. So you can do the calculation, find the x component, y component. Do the same thing for FB. So you have the x component and y component, okay? Now what is the x component and the y component for the resultant force? It's basically, you sum up all the x components. So this will be whatever for the FR, and this will be the y component of FR, okay? So you have the FR x component, you have the FR y component, and then you use Pythagorean theorem to find out the magnitude of FR, okay? Right, so you have x component, y component, use Pythagorean to find the magnitude and enter the answer in this spot. And then FC, you would get that value from here, so that would just go directly here, okay? And also, so you can calculate the percent error. So for percent error, because all these are actually measured values, so you will just find the difference of the two and then divide it by the larger value in order to get your percent error, okay? Now for theta C, this is already given, so you can actually enter that value in here. And then the x component and y component of FC, you have the magnitude and you have the angle, so you can actually resolve the vector of the x component and the y component. That you can also do the calculation. Okay. Now for FR, for the theta R, so how do we, for theta R, how do we do the theta R? I just want to draw your attention to that, because you will use smaller angle. Okay, so in other words, let's say so theta. So that's, let me bring this up first. Hold on. So you have the so let me draw it here. So in order to determine theta R, this is, you have to draw it on the XY axis. FA is in 0 location, 0 degrees. FB is 95, so this is your FB. Okay. So your theta R is right here somewhere. Okay. So and then your theta C is 240. So this is your theta C. So theta C is measuring all the way from here. So that's your theta C. Okay. And then theta R is this. So that's your theta R. So you need to calculate theta R, and based on, so again, if this is FR, if this in the second quadrant, I don't know, you have to do a calculation to see whether it is in the first quadrant or second quadrant. Let's say if that's in the first quadrant, so you can define this angle theta R as your theta R, and then use the inverse tangent, the adjacent to the opposite over the adjacent to get your theta R. And then in order for theta R to be comparable to theta C, which is pointing in the opposite direction, you have to flip FR in the same direction in order to find the difference. So to do that, so you calculate your theta R, and then you add 180 degrees because you flip it to theta R, then you'll get this. So this is the angle that you're going to use to compare to theta C in order to get the percent error. So again, find the difference between these two angles and divide by the larger angle will give you the percent error, okay? The reason why we have to flip theta R in the directions of theta C is that way we can find out the difference, okay? Because you know, they alone they align in the same along the same axis. So you have to flip one to the in the same direction, you know, to make the comparison. Okay, so that's basically let me see. That is basically you know, what you want to do for this week's lab. It's pretty straightforward, very easy. You just follow the steps in the analysis. And as I mentioned, you know, you just do this part. You do not have to. You don't do this part, okay? And then you don't. And then you process. You know, you do all the calculation listed in table 2. You don't have to do the graphical method. So this part is also, you don't have to do that as well. Okay. So just download the data from the lab data, and then work from there. So for this particular lab, you know, the focus will be on calculation. So you want to make sure that you know, show all the sample calculation. You don't have to show for every force. Let's say you know, you just need to pick a force to show how you get the components, and then pick a force to show when you have the X and Y, how do you get the theta R, and then you need to show how you get theta R, okay, because theta C is given, and then show how you calculate the percent error. Just pick one of them, you know, just show one will be enough, okay? Alrighty.